Hello guys, so from what we have today, we have the integral of cos² dx. Now how are we going to be solving this particular problem? Solution. We should know that cos A plus B is equal to cos A cos B minus sin A sin B. Therefore, cos²A, which is A plus A, is equal to cos A minus sin A sin A, which implies that cos²A is equal to cos²A minus sin² A. Since we are dealing with x, we have it here that cos²x is equal to cos²x minus sin²x. Let's liberate this to equation 1. And sin²x plus cos²x is equal to 1. Equation 2. Now, from equation 2, let's make sin²x a root of formula. Therefore, you have that sin²x is equal to 1 minus cos²x. Equation 3. Hence, we substitute 3 into 1. By substituting equation 3 into equation 1, we have it that cos²x is equal to cos²x minus this now, which is 1 minus cos²x. So cos²x is equal to cos²x minus 1 plus cos²x. And cos²x is equal to cos²x plus cos²x, that is 2 cos²x minus 1. So our main aim is to get cos²x, and from here we can actually get cos²x to be cos²x plus 1, which is equal to 2 cos²x. Making cos²x a root of formula, we multiply all through by 1/2. So therefore we have 1/2 in the bracket of 1 plus cos²x, which is equal to cos²x. So in other words, you can actually substitute 1/2 in the bracket of 1 plus cos²x to be cos²x. So now looking for the integral of cos²x, which is now 1/2 in the bracket of 1 plus cos²x dx. We now bring out what? The constant. So we have 1/2 in the integral of 1 plus cos²x dx. Now integrating 1 with respect to x, we get x, and integrating cos x, we know that we get sin x. Therefore, integrating cos²x, we have sin 2x all over derivative of 2x, which is 2, plus the constant c. So therefore, by distributing 1/2, we have 1/2x plus 1/4 sin 2x plus the constant c.